Okay. Yeah, so interesting thing is, so I have this quite beefy. Oh, I can actually do full screen. That's gonna be nicer. I have this nice beefy. Oh my god, I have to log in now. Right, give me a sec. Trying to log into Bork. I have this beefy laptop that's got AMD Ryzen 7, but it's got only integrated GPU, which is the AMD Renoir, I think. And I had it. Loris helped me set up the OBS on Linux a while back, and he suggested that I should use hardware encoding, but I think in this case hardware encoding is not such a very good idea, because I think it's not able to catch up, like to keep up with the stream and stuff. So I think software in this case, like just CPU is better. We'll need to listen to a local host. Yeah, sure. Token. Twitch token. Sorry guys that you have to go through this. This is going to be hopefully a one-off setup, but I'll have to do it right now. Copy. Yes. Awesome. I think this should be us. Why is it disconnected? This is awesome. Right, is Lotus here actually? Oh yes. I'm trying. Wait, I will show you. I'm trying to set up Bork. So it should be running in this small window here. I did the like open authentication token and stuff, but it just says disconnected. And I'm wondering what's up. No. The Macho Man. Oh my god. This is going viral. I hate that stuff. Can you see it, Loris? Should be that one. I can... How do I run quit here? I don't see any input or anything like this. Oh. Can I like... Why does it not like go away? Oh my god, that's amazing. Show me what? Oh, I got it. Okay. So wait, so work config. Config v1 is it? I guess so. No, obviously I'm not gonna show you the token. Should I just like launch a command or something, like connect or? Okay, so then we do Bork quit. Nice. Interesting new problem, thank you. So I assume I do the Bork start in the actual window where I want the chat to appear, right? Not in the yeah, okay. Bork moment. Hi, Andrew. Andrew, you should be asleep, man. It's Borkin. Yeah, it definitely looks like it. Is there like a log somewhere? No, it's not a Mac. It's actually Nix OS. I'm on Linux. Ta-da! Because I'm happy to debug it. Is this a debug build? No, it's release fast. Gotta go fast, right? So are you telling me that I should never do that? Don't. Oh, nice. Right. Okay. Okay, this is gonna be tricky. Not with Bork. So I have Bork in it. Now you BMO. Probably. Oh, this is great. So actually I have a question, Loris. Yeah. Loris, do you by any chance have updated to allocate? Probably not, have you? But that's okay. Yeah, okay. That's fine. Wait, I don't want to do that. I want to do it fresh. No, actually, I don't want to pollute that stuff. Just give me a sec. I'm just going to rebuild it before I allocate. Yeah, that's okay. Oops. I mean, I tried yesterday, but it didn't appear that you have applied the. Yeah, you should make it release. That would be nice because I could just pull it instead of rebuilding it with a different version of Zig. But that's okay. That's not, you know, it should be pretty quick. Good work here. Where are we now? Bork. And yeah, I do have some changes already. Yeah, it should be okay. And you need to definitely make changes like soon, Loris, because 0.9 is, you know, is incoming. So yep, it's the 16th, right? It's like time flies. Exactly, yeah. Oh, sweet. Oh, so this is the 10.33.9. That's the Leap C, right? I think. Andrew, let's have a look. Well, it's a lot too big. Oh, come on. No, yes. A 0.10 win. I think in 6 months, roughly. Maybe a bit later. We'll see. Yeah, okay. I can definitely help you with this at some point because Andrew, I can definitely run the full test suite as well here because I was meant to do this, but I didn't get the time yet. Yeah, there will be a 0.9.1 for sure. Okay, you're running locally overnight. Okay, cool. I still, I still want to know how to get all the glibcs anyway built for enhanced testing as well. So I'll definitely get on that. Oh, and by the way, since you're here, we can actually quickly discuss. Do you want to like? What was this stuff? Okay, so you bumped it to 0.10. Okay, cool. You know the needed stuff. Oh yeah, you've got time. Look, you can. I think you're fine with the WASM linker. You're way ahead of everybody else anyway. So. Right, I think it's built. Yay. So let me just get rid of this stuff. Okay, so Lotus, you're saying just to build it in the bug. I am nice to look. Obviously I'm nice to look. Come on. What DE? What does it mean DE? Ayush, what's DE? What do you mean? Oh yes, desktop environment. Yes, is GNOME. Yeah. Yeah, it's the it's pretty much the default that Ah, thank you. Look, so nice of you. Yeah, see, Andrew. Yeah, it's GNOME. It's the default that was with basically with NixOS. I just decided not to even like not to do the slightest of configuration stuff. Like basically just roll with it and see how it goes. But the terminal emulator is Kitty. I was suggested that last time, and it's actually very good. I really enjoy it. It's super fast. I'm surprised. I thought Alacrity was the fastest, but I stand corrected, so that's cool. Okay, Loris, I have Bork. Are you ready? Wait, that one. I'm gonna and then I have to. No, wait. The token is there, so that should be fine. Yeah, I think it's the same thing, man. Bork test? Still borked? Oh, thank you, Ayush. Yeah, trying my best. And I have logs though in Bork. Okay, so wait, we have logs. Let's go to logs in .bork. We do have logs. Nice. Oh, nice. Look at this. A socket not found. There we go. Oh, thank you, Andrew. Yeah, I'll do that next time. That's yeah, obviously. Dash P is a good option to have. Yeah, okay, so there's that. It seems that there is a problem with the socket, so anybody's happy with this? Lawrence, any ideas? Because I maybe I did something wrong. Maybe the default socket is not, maybe it's like taken or something. Should I change the port? Could do that. Don't know if it's gonna help. Oh, not here. Oh, that was close. Yeah. Could it be my... No, wait. I don't think I have a firewall like this. Should be fine, right? I mean, this is not like... socket not connected. Yeah, connection so we were meant to be doing I'm happy to help you with this. I know what we were meant to be doing x86-64, but you know, since this is obviously failing, unless, do you want, like, maybe Andrew, do you want to send me Borg that used to work for you? Because I'm on x86-64. Yeah, it does sound like it. Do you want to send me the binary, maybe? I'm on NixOS as well, so it should be fine, right? Maybe. Let's see if Andrew wants to send it to me. Unworking Borg, yeah. It was meant to be something else, but that's fine. Can you just, to be sure, redo the token procedure? Sure. So, okay, it's crashing itself. That's nice. Yeah, definitely. What? It said it? What did it say? Oh, got it. Okay. You cross compile for this machine. Yeah, that would work, right? Yeah, I saw that. Yeah, in the logs. Yeah, wait. Let's Borg log. Yeah. And properly format. Okay. So wait. Yeah. I don't want to do it in here though. How do I? No. Control Shift N. Yeah, there we go. I'm gonna do it here in the privacy of my window. Let me have a look at the token. Oh wait, what? That looks like the wrong token indeed. Huh. And this is gonna help it. Yay! See? Debugging on the fly. Woo! It was me being an idiot. What do you know? Yes, see, Loris, you're a genius. That's amazing. Nice. Okay, cool. So now I don't have to look at the other window. That's amazing. Sweet. We have Borg in the house. Borg moment. Yeah. So now I regret that I don't have it in release safe, you know? It would have been so much faster, right? Hello. Simeon. Right, okay, so what were we meant to do here? I think it was it stage 2 that I had it as? Yes. Hey, excellent. So I don't need actually that, I already have that built. Swedish chef from the Muppets. Oh my God! Did you know, Andrew, that my daughter absolutely loves the Muppets, the Sesame Street and stuff. Like we have it, like the music on repeat all the time. Yeah, that's okay, Loris. It worked in the end, and I'm happy I did some debugging with Borg and you, so that's okay. So if you have any like hints how to use Borg, in the sense that, you know, typing in some kind of a secret command or something, like, just shout out, Loris. And in the meantime, let's have a look at CodeGen. Borg help. Okay. So if I do send live Zig coding with KubeCon, I'm not gonna say Machoman, hell no. Nice, this is cool. Oh, ban. Wait, Christoph IT. That's gonna work, right? Open. Oh, Control Shift. Sweet. There's no unban. Oh, what do you mean? So what happens then? But there is unban. Ban unban. Sorry, Borg unban. Ban unban. There is Borg unban. Ah, nice, man. Yeah, okay, yeah. Zig is actually really. Zig is really cool, and it's really actually it's meant to be simple. So you know you should be able to pick it up. You should be able to pick it up quite quickly. So yeah. But if you have any if anything is unclear, just feel free to ask and stuff. Okay, so back to the issue at hand. So what is happening here? Borg AFK. Serious? With like what? One like PP time? Nice. That's cool. What, PP time? Andrew needs something. Or you need PP time? Or you need Borg AFK? Oh, Borg PP. Yeah. Right. So what we're looking at here is stage 2 code gen for x86-64. Luckily, we are on x86-64, and what we want to do, we want to clean up MIR instructions, because I messed it up a little bit in the sense that, so MIR is this middle-level intermediate representation. So basically, we have a couple of stages in stage 2 code gen. It's actually stage 2 compiler. Notice, does the AFK actually disappear? Yes, it does. Okay, cool. So we have a couple of stages. We have AST gen. I think then there is ZIR, which is untyped. Oh, good night, Andrew. That is like untyped. Then we have AIR, which is typed front-end analysis of all the tokens and everything in the grammar, I guess. And then we go into the MIR, which is already targeting a specific backend. And then MIR is going to be lowered into actual instructions. So the ISA, like in this case x86-64, and then that is passed to the linker, which then produces final binary. So if you watch Andrew's streaming, I think he's mainly streaming the front end work of stage 2, and I'm mostly doing the backend stuff. I don't know if Luke is streaming. He's doing the backend stuff for WASM, for example. I'll be mainly doing the x86-64, including linkers as well when I get to that. So, but I definitely will at some point. So basically, an x86-64, and this is just to give you guys some context. Yeah, there we go. Perfect. We have. By the way, this is a very cool reference for x86-64 instruction set architecture. It's obviously, if you want to know more, you should look up the manual, but the manual is pretty big. It's like, I think, over 1,000 pages. Obviously, you don't have to read everything at once. You can just pick whatever you want, whatever you need. You have nightmares of this page. Look, no, it's okay. Actually, once you get used to it, it's fine. It's just that you have to be able to decipher the Okay, so is it like going too loud or something? I can turn the gain down. Is that any better? Yeah, so let me know, please, because I'm still tweaking everything. Okay, cool. So just deciphering what they mean by different acronyms here. Yeah, no props. Yeah. Shout out if anything is wrong or anything is blurry and stuff. It's funny because I had to like turn it up when I was on Mac, and then now I'm on Linux, I have to turn the gain down. Crazy stuff. So for example, here we have our favorite instruction, which is going to be move, standard move, just move. Oh my god. There we go. And this is like this wall of tears. I guess we have a lot of like basic instructions. Then actually all of this stuff is kind of hiding instructions within as well, because this r/m16 means that you can actually move it into register or a memory via register, so memory operand. And then we have different like OP, I guess encoding types, like op kinds, like MR meaning memory and then register memory, and then MI is memory operand and then immediate. And these three are the ones that hey Hayes, are the ones that we're gonna focus on now. And the mistake I made is that, so for Intel you have two types of like people tend to write in two different ways. I think that all the debuggers by default work in AT&T syntax style. So that's source destination. When you write out the op, it's op, source and destination. And then for Intel, is the opposite, is like source destination, so the opposite way. And Intel is just easier to read. And the idea is that we want to have everything being in Intel style, especially because even when stuff is being passed through air, like from air, sorry, as you're going to see in the code gen, it's also kind of that the destination register, for example, comes first. So destination, then source. Or that's how we actually organize code, because that's how we think. Like Andrew thinks this way. I'm also used to Intel syntax by now. Oh. Hazy so. Okay, hazy code. Oh, I'm sorry. My apologies. I had no idea. Thank you, Loris. Haze is Soul Serpent on Twitch. Okay, Soul Serpent. That's a very cool handle. Okay. Right. So basically, so the way I did MIR was because I was still getting confused at that point, and now I'm getting more clarity about all this stuff. I did it in the AT&T style, and then the rest of the stuff is in the Intel syntax style, which just makes everything so much more complicated for no reason. So for example, if we are talking about move instructions, so actually I fixed that one already, because this used to be the opposite way. It used to be like this. And then you have register 1, which is RSP, and then register 2 is RBP. But actually, the end instruction, if you look at the disassembly later on, is actually an Intel syntax, is this. Right? We're actually preserving RSP in RBP. Am I right? I think I'm right, yes. Yeah, so the destination is obviously RBP and then RSP. And that's what we want. And I already fixed that, but it was the opposite way around. And this is kind of confusing and not very good. The thing is actually much simpler for single register operands, operations, sorry, because, we just have to deal with immediates. Although, for that one here, for example, I'm actually going to explain what the flags here mean, but basically we encode a pair of registers, and we also add in a 2-bit flag into it so that we can actually compress the used memory. to be able to select the correct instruction. So, or actually encode what the possibilities are later for emitting. And this is what it means. We have a couple of flags. This is for ADC, but this the same logic here applies to move as well, because they share a lot. Move actually shares a lot of ops with encodings with arithmetic operations in x86-64, so you can actually encode them in the same way, almost. So it just becomes less cluttered. Although there are some changes and differences, maybe we'll be able to work them out today, actually. So yeah, so the first one is the destination register is reg 1, and then source is reg 2, as we saw. And if this is RSP and reg 1 is RBP, then we preserve the contents of RSP and RBP. And this gets the flags 0, 0. Then if the flags are 0, 0, but register 2 is none, meaning that we don't have the second register, we basically transform this operation into basically moving some immediate value into the register. And so on and so forth. So we use not only flags, but we also use the fact that if register 2 exists or it doesn't, then we do different things. This one is tricky. This one is, I think this is the direct, what was the S? I think this was actually taking the absolute address and just moving that into a register. This works only for static binaries. I'm pretty sure we are not allowed to do that for Pi. So basically that would not work on x86-64 macOS if it's compiled as a position-dependent executable. And by the way, ZLD doesn't support anything at the moment. Like, we only support Pis. Sounds weird. We only support Pis for macOS anyway, because ARM64 has basically the kernel on M1 is banning non-Pi binaries. So I know this is technically not super backwards compatible for x86-64 macOS, but it's just easier, and we don't have to worry about all those tiny details. But if there is like a genuine need for this, we can definitely look into that, because this is definitely going to be added for ELF linker that I'm working on as well. Okay, so basically every reg 1 should be the destination register, and then reg 2 should be the source register. And this is we need to tweak stuff in two places. We have there are like 3 files that kind of represent the pipeline here. We have so the first one is CodeGen, and inside the CodeGen we have this magical function called generate, and this is CodeGen generate. This function is actually called from the linker. Each linker, let's see, for Mako for example, each function is calling, each linker is calling generate function, which is in like a common CodeGen bit, and then that one, depending on the architecture, it's picking what to call next. And for x86-64 we call generate. We were just looking at here. So that's basically the entry point into the CodeGen when we want to generate the instructions for a decal, like a function here. I'm not sure whether this might also be the entry point if there is no function, but this is going to be an interesting one to look at, like global variables and stuff like this. I don't know if we can handle this yet, but it's definitely interesting to have a look as well. I might take a note later. So we create a function, and then we pass in, where is the MIR? Wait, that's not, no. Nope. We pass in air, which is in line 27 above here. But then where is MIR? Oh, here it is. And then we generate air instructions for that function. Then we create MIR. Oh no, wait. Yeah, okay. We already have some MIR instructions done. So we create the MIR structure, which we will then use as kind of like a container to pass it to emit. And then emit is taking all the MIR instructions and actually creating actual opcodes, like instructions with them. So it's loading into x86-64 ISA. And this is happening in emit MIR. We just switch on tags, and we do everything that's required, including relocations for any jumps that we might have not fixed up yet. So we can have jumps that, I think we actually don't fix up any jumps until here. And I think this happens, yeah, we have it here. So fix up relocs, and this is for jumps in x86-64. For like defer in Zig is going to be handled this way with fix up relocs. This is another thing I might do on stream. Currently, this is pretty dumb in the sense that it assumes every jump is going to be 4 bytes, I think, as far as I remember, which isn't, it's not very efficient because some of the jumps can be, near, some can be far, and they don't have to exactly take 4 jumps. So we can select a better instruction here and optimize it out, but I haven't done it yet. And this will require some recursive optimizations through the MIR tree, I guess. So this is definitely something we might do on the stream, maybe, if it's not going to be too difficult. Or if it will be, then we'll just wing it. Okay, cool. So so basically move. Let's focus on move first. Move is lowered with MIR arithmetic as well. I think I even left a note here that that's the case. I'll leave it as it is for now. I was thinking, because move has got a lot of different like additional variants as well, in addition to what arithmetic instructions have, like the for example, moving the actual, like, oh, this is segment and offset, right? Yeah, so this is the absolute address within the segment. That's the DS colon as a memory, kind of like a memory operand. What I mean, like, let me show you. This is this notation Intel is that one. This is with respect to the segment, and actually we take a position within the virtual memory, which obviously not going to work for pi, as I was saying. So it's part, like, it's basically lowered using the same code as every arithmetic instruction, excluding multiplication. That's a different beast altogether. But maybe it should get a different one, because maybe we want to encode more, or maybe we want to split it into more MIR instructions as well. These are cheap. Like, I think we have used to the power of 16 potential tags. Let me have a look. Yes, we have to the power of 16 potential tags. We're definitely not there yet, so we have a lot of possibility for expanding. We have a separate one for move ABS. That one is a separate instruction, and it allows you to, on x86-64, it actually allows you to move a 64-bit immediate directly into a register, which is pretty cool. So we're also missing all the SIMD and floating point registers as well from here. Like, we didn't even have that yet, so not there yet, I guess. Anyway, so that one is fixed now. I fixed it. We'll need to like rework this stuff. What is happening here? We have this helper in x86-64 codegen bit, which is called the encoder. This is effectively an abstraction over, I don't have the AMD manual open, but basically this is the abstraction of how to encode all the stuff in, for the CPU to understand. And contrary to what you do for a RISC, in this case, depending on, it's a variable length encoding effectively for x86-64. So depending what the next byte is, the CPU will expect something else. And sometimes registers are encoded within the moda RAM. Sometimes they're encoded within the op directly, and things like this. And then basically the encoder should be able to help us do this in a more abstract, readable way, rather than being exactly, remembering exactly where to add which bit. from the register for this to work. Although I think you always push them like as a complete set of bits. You don't do the same thing as you would do in a RISC, where it's actually split across different bit fields of the instruction. But anyway, so yeah, we have the rex prefix. That's only, like, this is typical. It doesn't exist on x86. It only exists on x86 64. This is to select basically the width of the operation. Is it 64-bit or not? And this is something that I also need to clean up. I'm not sure I did a very good job with this. I think sometimes we select not the right size, or at least I did when I was testing on Mac OS. It was behaving in a different way to what behaves on Linux, which is surprising. Then we have the R field is basically saying, like, if we have a extended register field in the mod RM byte. X is actually extending the SIB, so this is the scale index base, I think, field. So this is mainly for scaling, although some of the stuff has to be used for certain displacements as well, I think. So this is the most confusing bit, and I might be talking crap here because I don't remember it off the top of my head, like everything. I did do some analysis of this stuff. And then B is usually used to extend the RM field in the mod RM. So we have two fields in the mod RM. One is reg, one is r/m, to basically if it's an extended register or not. So this is also important because we can have R11 and then the encoding is the same as for RDX, maybe RDI, can't remember. And then if we add the extended bit, then it's going to be flipped to R11. I think that was the case. Okay, so what we're gonna do here now, we don't want the linker at all. So this looks fine. Here we have an immediate, so this is actually a lot, like, we don't have to actually fix anything here. We have the opcodes properly set with the register and the immediate. This one is fine as well, but the problems will appear where we have two registers, because I think these should be the opposite way around. Let's have a look. Let's have a look in our flags. Yes, I messed them up. So this one should actually be, wait, this is op, and then we have, this is for, wait, which flag is it? Okay, 01. That one is 01, so this should be, oh no, this is fine actually. So this should be, okay, so this one should be, we take the register and on some offset, we dereference the memory. So we basically look at the memory there, and then we pass it to reg1. So that's our source. That's the source, reg2 plus immediate 32 as a memory operand, and then we have the destination is reg1. Don't need that. We can actually get rid of this stuff. I just needed this not to get confused with the manual. Right, okay. So we work out the size based on reg1, and I'm not sure whether this is actually exactly right, because I'm not sure whether we should we wait, and then reg1 is that one here, right? And I think, yeah, so they are so reg1 is actually the one that's actually here, reg2, because that's the memory operand one, if I remember correctly here. So these should be reversed. And then if we look in the code gen, let's have a look at, I don't know, some other move. That's fine. This is, that's 1 0, so no. Oh, okay. Have a good one, Lotus. Bye. Move ups, 1 1. Load effective address. No. Okay, this is 0 1. But this is, yeah, we have both registers, so this is easy. Oh no, wait, this one actually is a special case, I guess, is it? No. Okay. Oh, excellent. Right, there we go. So, what are we doing here? And this is stack offset, and that one is what? Memory register. Okay, gen set reg. So I think here, what is happening here? I think we're setting the register with the value from the stack. Oh, really? The video, so the sound is desynced. Okay, wait, I think I can fix that quickly. No, not scene durations. Nope. Wait, what is that? How do I? There was a way. Property. Ugh. So there is a small delay. So basically, my voice is. It's better now. I didn't do anything. I actually did not do a thing. So, but wait, if it's like coming, is it like? Is the voice ahead of the video or is it the opposite way around? Okay, the voice is ahead. The voice is ahead. So wait, if the voice is ahead, I want to delay it, right? Let's try this. Oh my god, stop disappearing. Is that any better? Yeah, is it okay? Because I don't know whether to go positive or negative on the offset, so it's one of the things that always confused me. Testing, 1, 2, 3. Yeah, so basically I set the sync offset to 300 milliseconds positive. So okay, so this way, okay. I don't know if you guys have it as well, but whenever it comes to like actually offsetting stuff, I can never like work out quickly whether it's a positive offset or negative offset, and the same with and you know with stack as well, obviously, because everything is reversed, so it's even more confusing. So I always get confused about this stuff, and then I have to actually either I take a pen and pencil, just write it down, try and figure out which way to go or similar. Right. Anyway, so here. So the source, we want the destination to be right. So this one is actually, wait, what are we doing here? Maybe this is correct actually. Right. How can we check this? How can we check this? How can we check this with some nice example? Let's try and work it out. Yeah, maybe. It might be worth. Maybe I should add like a simple unit test here for this stuff. I'm just trying to figure out whether we should encapsulate this stuff in a standalone function. Unless, do we actually have anything in here? Yeah, okay, we have simple move. Okay, maybe this is gonna help. Because what I want to test here, I would love to be able to basically say, MIR, register 1 is this, register 2 is this, flags is this, and then I would expect that to be emitted as. Because without this is becoming pretty confusing. And I want to avoid having to basically, like generate some dummy a binary and then do a dump and then see whether, you know, what we wanted is there. I would like to be able to actually do it like in a more structured way, but I'm wondering how to do this best, because the way the thing is structured currently is not, I think, allowing for this to be easily added, but we do have add instruction takes an MIR. So it takes in that instruction. We do have data, so we need to have a slice as well. Trying to figure out if this is what we want exactly. And then here, so we have the index, we have the ops. Yeah, maybe just mock it. Yeah, that's my daughter, by the way, if you can hear her. Since she's back from her walk, she might be quite loud. So what would that look like? Because then we had an encoder. We have the, oh right, what is the emitter here? Jesus, I wrote it so... I think I wrote it only like a month ago, but I already managed to forget everything that I did. Okay, emit is this structure, obviously. Where do we push the output? Target, source log, code. Obviously it's gonna be code. Yes. Okay, emit MIR. Code, offset mapping, that's okay. I think that was for locations. Instruction plus mapping, which is fine. Oh yeah, I definitely need to add some tests to be able to test that stuff as well. So yeah, this might be worth doing right now. And then we have that stuff. Right, get rid of that. Okay, so we decode the ops, which basically allows us to pull registers and then effectively any extra data if we have it. We run the encoder on the code, right? Okay, so this is the slice that we are saving it to. So we had this is just a buffer, right? So we could, and this is the buffer that we own. That's perfect. The only thing that we don't own is MIR, so we need to spoof that. We need to spoof that, but then we could actually have something like add instruction here as well and test it out. And that would be pretty useful. Right, so here we have add inst. It's that one, add extra, assume capacity. So for the moment, let's just copy it over, I guess. So this is gonna be just for testing. Let's call this, I don't know, like MIR mock maybe. And then we can add that in. Oh yeah. Is MIR pulled in here? It is, cool. So, and then GPA, we actually should probably just take the testing allocator. And MIR mock instruction. That's fine. Let's leave that in. Like that's okay. I think just GPA will be fine here. Right, and then we also need MIR instructions. So MIR instructions. So basically what I'm trying to do is I I'm literally copying everything over just to be able to like mock it, I guess, in a way. I mean, later on we can clean it up if it actually proves useful. But I think something like this is needed, desperately needed, to be able to, if we add any new MIR and we want to lower it to something, we need to be extra careful how we lower it, because otherwise, actually, you'd be surprised about actually lowering it in the wrong way, like in the wrong order, or for example, even sizing, if it's wrong, Jesus, tracking this down is horrendous. But a cool thing, actually, yesterday I managed to debug x86-64 code directly on the M1. So with Rosetta, obviously, and it worked okay. I heard some mixed feelings, mixed opinions about this, that LDB works okay, but for bigger code bases, your mileage may vary. So, right, let's go back to CodeGen, and then MIR instructions. No, I think the allocator within the testing thing is already doing this for you. I might be wrong. Let's have a look. Actually, it's a good shout. Yeah, see? I think we're good. Just it's basically re-exported like an allocator now, after allocate, if that's what you mean. So I think it's fine to just have allocator in the global scope. Yeah, but yeah, that's true though. Everything changed. So this is what's coming in 0.9, and this is a big change. This will require like a full basically every code will need to be updated. It's not a big thing though. It's just that you have to get rid of the pointers where you were passing allocators. It's just an allocator as a struct because it's just a wrapper, and then you basically, the way to get the allocator from the parent allocator, for example, is via a function call rather than a field. So not, it's okay, it's manageable, but it's a lot cleaner now. That's for sure. Right, okay, so we need this stuff. I don't think we care about anything else. So we can get rid of that one. Right, okay, MIR extra, sweet. So this will hold the extra data. MIR instructions will hold all the MIR instructions that we are spoofing here. It might happen that maybe we don't need that much, depending on how much we will be actually mocking here. This might be useful. I'm thinking for mocking jump relocks, basically for fixing up the relocations for jumps. Because trying to work this out, I guess recursively is going to be. Oh, actually, wait. Be better, I think now. Trying to work this out, it's going to be a recursive thing, and then it might be difficult to track bugs in the final binary and stuff. So okay, so we have a MIR mock, that's fine. Result, I think that should be fine here. Don't need the pub mock extra. Have allocator here. We do not. We might as well add it. Oh, in the final binary. Why would it be more difficult to track bugs? It's a tedious process, especially if you have, like, for example, let me give you a quick example. Where do we have the tests? Oh yeah. So one of the things that I was tweaking yesterday were stage 2 tests. Let's close that. Spelling, what do we have? Yeah. See, if you have an example like this, as got add and mul, and there is a mistake somewhere because you get an assertion fail, trying to track where that is coming from is hell. Like seriously, like because basically this is testing register allocation that we still need to work out, like for it to be better, plus splitting registers, and it's there's a lot, like there's a kind of nice mix of moving from and to registers, obviously arithmetic operations like add, but there's also there are also like memory operands at play here as well. So everything matters, like where it was saved, what, if we're actually, instead of like moving from the stack into a register and then adding, we can actually use the memory operand to do it at once. And if we're doing this, then we have to be extra careful, like the size of RBP. Is it meant to be 8, 4, 2 bytes or something? If we actually don't do that properly, then we might be reading junk. And I would like to avoid this, basically. So one of the things that can cause an error like this, except for the logic of actually generating the proper MIR instructions, is also how we lower it. And that's what I'm trying to test now. I want to be sure that when I'm lowering move from MIR, the MIR I wrote is going to be exactly lowered to what I intended, rather than having things like flipped or wrong sizes or things like this. And this is what I've basically been fighting. So this is, I think it's my negligence here. I should have done it nicer in the first place, but gotta fix it now. So does it make sense? I hope it does. My remark. Yeah. So and the other thing I'm maybe we'll be able to stream it. Maybe I'll be able to stream it tomorrow. The other cool thing that I want to show is adding helpers for MIR, because at the moment, wait, add in. I mean, this is okay, right? The way we have it now, but this is quite a mouthful that you have to specify the tag, specify the ops by hand, and then do this crazy encode stuff. And then, you can leave the data undefined if it's never going to be used, and things like this. And this is, that's quite a lot. So Andrew's suggestion, which is actually a great suggestion, was like, why won't we add a helper for this? Instead of doing this, we could actually do, try self. Oh, nice. Look, yeah, exactly. So you can have a look at exactly, yes. And you can do like move, and then have RBP as the destination, and then RSP as the source, and whatever else here, like, I don't know, like empty thing. Right, and this is much more readable, and it actually looks almost like what you would expect in the Intel syntax, right? You would have like a lot cleaner instead of having this with the confusing reg 1, reg 2. So I think this is worth adding as well. And I think I already started doing some stuff for this, so I might finish this on stream as well, if it's of interest. It's actually fun doing this stuff. It just, I guess you have to be patient, because things always go wrong, and trying to debug this stuff requires, we're basically going to be pretty knowledgeable about GDB and LDB, because you have to look in the register, step in the instructions, look what's on the stack and things like this, and it's pretty funny. But anyway, okay, so we have this, we have add instruction, add extra, assume capacity. So that would be the mock. Okay, so let's just do mock for now. How would this work? We would like to create a MIR mock, I guess. So or even call it, and then MIR mock. I think that should be okay here. And then we would like to do add instruction, right? And then let's copy some stuff from CodeGen. And initially we can just test this stuff because it's simple. Okay, so that adds a new instruction, and then what we actually want to test is not adding MIR, which we have, but actually lowering this stuff. So wait, where was the emit? Okay, so I think we need to create emit. Oh, we don't need that, we don't want that, okay. Do we actually need the bin file? because we need the allocator. Okay, I think we're just gonna do this. And allocator, 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 allocator. Ah, right. Okay, so for load effective address, that's not gonna work because we need actually the bin file to be able to cast to a specific linker backend. Ravi, what do you mean socket lib available in Zig? Are you asking if we have one? I'm actually not sure. I don't know what we have when it comes to networking. I think Luke might know because he's created an HTTP server, I think. Or Loris, but he's out for lunch, so. Right, okay, so we want to bypass this. I guess we just want to call arithmetic. Just that one, and actually we could do it this way for now and see how it fares. Arith, and then have what do we need? We need instructions. Oh, actually, we need MIR. And then inst index. Oh, right, not this place. We want to do it here, and then let's call it imp. Doesn't really matter that much here. Let's take that stuff. Add them in here, and then here we would just do impl, and then we would just pass in mir, emit mir. Oh, we also need emit code. We could do that at the end. That's going to be, I think, nicer. Inst emit code. So we need code to write to. That's fine. How to talk with Python program to the TCP server. I think there should be like some Ravi. There should be a way to create a socket. I think in Zig, just listen on it, even like synchronously in a while loop or something. Right. Okay. So we have this is not needed, and we don't have any emit anymore. That stays. Encoder stays. It's fine. La 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 la. Actually, any sort of emit is gonna go. Okay. 81. Too many dots. Right, cool. Okay, and I think this actually, I think this should be what we want here. So do I have, yeah, I have, So let's just actually let's test it. It's gonna be quicker, but we don't want to run all the tests, and I'm not sure whether I can disable them with stage 2. Wait, one sec. Test stage 2. Need chemo, but can we actually? Will this work? I've actually never tried it. That didn't match this filter. I don't think they will. We don't have a. I guess if we had them prefixed with x86 64, unbelievable, 64, that would work. But I don't think it's gonna work now. Stu.net stream server is a basic CPU server. Makes it easy. Oh, makes it makes it easy to open a socket and listen for a client. I think there are tests that illustrate this. Yeah, and I think Luke's wait. Let me quickly maybe pull it up. I think. Luke, you had it. What was it called? Apple Pie, right? Should be an example here, right? Unless, yeah, maybe that one. Oh, let's test it out. Next row. Yeah, I need to, because I don't have Bork in the path otherwise. And then what was it, Bork? Ha! Damn! Lotus is a genius. So cool. Okay, cool. Emit code. Oops. And encoder init, I guess, assumes, yes it does, an array list, and that's fine. Emit, absolutely fine. I'm gonna tweak this a little bit. To the array list, that should be fine now, and then emit code. It's already a pointer. Excellent. Just give it a minute. Like if it's gonna run the compiler error tests and the front-end tests, I'll just kill it and just comment it out, and then maybe in my spare time I'm gonna have a look if I can add some filters in so that we don't have to do that every single time. I actually I'm pretty lazy. I should have done it in the first place in the past, but yes. Not cool. Maybe we don't even have the filtering stuff in yet. But that's okay. That is fine. We just need to go in cases. Let's say, yeah, maybe we should have some kind of a filter here or something. And just do that. Oh. How programs talk with socket. Oh, okay. Yeah, unfortunately, Ravi, we don't have like docs or doc generator implemented yet for sound library. Plus, it's changing a lot. So, yeah, and definitely you should try that. I think it's gonna be a great learning experience, and you're gonna get a better handle at Zig all in all if you write your own server. But yeah, we don't have documentation yet. But as Luke was pointing out, if you look in the basically look at tests, a lot is there. You can actually deduce a lot of the stuff, and they actually document a lot, so it's pretty good. Okay, I think we're good here. Maybe not. Oh, it leaked. Why? Well, okay, because obviously I didn't. That's for the tests, I think. I added the instruction. I didn't clean it. Wait. That's for that one. Should have definitely. No. Yes. DNet. Fire mock. We need to pass an allocator, right? Yes. Because it's multi-array list, and then this one is unmanaged, so we need to do the same thing. I think this should actually give us a green light. Yeah, we have some tests. Where's the stream? Was the stream server? Yeah, there you go. There we go. Yeah, listen on a port, send bytes, receive bytes. Yeah, I think this is a pretty good example here that both Luke and Hazy Code were talking about. So, oh, there's another one. Oh yeah, this one is an async, and that one is that one not async? The first one? Maybe it isn't. Okay, excellent. So this is good. So we got that, and then what we want to do here, I guess. So MIR mock should also start. Actually, we don't need to start it, to be honest. We could actually, yeah, okay, maybe. Meh. Just cleaner DNet. Okay. Let's have. Actually, yeah, okay, whatever. Let's leave it unmanaged. It's fine. We can actually have it already like initialized with an allocator because we have it globally here, so it's fine. But anyway, we need code. We also need what else do we need? MIR RF implementation. We need MIR because this is going to give us instructions, but we actually don't want that. We want to unpack this stuff because we have our own stuff here and we don't have an interface for this. So we will do that. Okay. Okay, and then right, okay, cool. That should be the instructions handled. So we need MIR instructions, which are, what are they? They're a slice. Oh, excellent, there it is. So we need it's multi-array list inst. What is inst? It's MIR inst slice. Let's do some formatting here. MIR extra data is not there, right? And we also need, is that the same thing as here? Okay, let's call it just extra. It's gonna be easier. MIR extra. That's a slice of U32s. Oops. Okay, and then MIR extra Oh wait, what I did something wrong here. Because that's a helper, and I'm gonna tweak that as well. Okay, right. Okay, so let's actually make that one. Like so. So we have MIR extra instructions, and that's fine. And then we're gonna have to unpack that here. I'm at MIR extra. 1, 2, 3, 4, 5. Sweet. Instructions, where is extra? Data, right, okay. So that one will take MIR extra. Does it need anything else? Okay, and then yes, exactly. We don't need that. Oh, I know. Let's be consistent. Oh, thank you. So DCMRRN wrote in Polish. That great job. Thank you very much for macOS stuff. Yeah, is there any way? But this is the Metal API, I guess. So there is no way that Zik can help with this, I guess. I mean, it would be cool if we had like some kind of a abstraction layer over this, but I'm not sure how feasible that would be. Extra sweet. Because I can tell you that there's more exciting stuff to come as well. Some things that might not be visible like upfront, but I am hellbent on adding DSIM. Basically, how you have the DSIM util, or whenever you're coding Xcode, and it's you can actually pick if you want the old school, old-fashioned debug symbols. So basically embedded in like the dwarf segments embedded within the object files, or you can pick Xcode to actually run DSIM util for you at the end and generate the so-called DSIM bundle. I already started adding some of the stuff, and it used to work a little bit, but now since we can link in object files in stage 2 incremental, I need to actually rework some of the bits, but I am definitely adding that as a native step. So DSIM util will be like bundled with the compiler by default. Whenever you'll be using stage 2 debug build, it will always generate DSIM bundle for you on the fly with all the relocations applied. So so this should actually, for release, this should be really helpful, because I think this is required. If you want to ship any debug symbols on macOS, you are obliged to generate DSIM bundle rather than use stub symbols for debugging. I think it was something like this. So there's a lot more to come. I just don't have enough. The day is too short. Extra data. And here, we'll just leave it as it is for now, but we're obviously gonna change. So extra data. And then wait, emit MIR extra. Okay, and then what's this? This one is the same. Emit MIR extra. And that one too. We'll be able to clean it up later on easily. if this actually works. We'll see if the mocking thing will actually work out. I think it should be fine. Met myr extra. One more between dots, full stops, yeah. Oh, this is nice. I want to have a look. Uh-oh. Oh, wait. Okay, there is one. Too many characters there. Okay, cool. See, this is exactly what I would love to have. There was if you guys must know Flu, the creator of Sokol Zig and I think Sokol headers. He has started a thing that I didn't really have a look. I have time to look at properly yet and help out with, but there was a thing. No visual. No. So-called name. Wait, can I sort by Zig or something? Or Objective-C? Yes. No, that's definitely not that only. What about Objective-C? That isn't one? Maybe it wasn't him. No, it must have been him. But anyway, I'll look it up later on. Somebody pinged me with an idea that they wanted to actually do exactly what you did, Hazy Code, for the entire Objective-C runtime. This is a lot of like work, obviously, to port that stuff to directly to Zig, but it would be so cool. Oh, and by the way, this is just a nefarious thing in Objective-C. This is insane, because this requires that if you specify a framework or a system library on the linker line, even though you don't actually link anything from it, if it's missing, then the loader will not load the library, and this will return 0. So you're gonna have a very, very, very nasty runtime back to track, like a segfault, like a proper one. So been there, and yeah. And this is shocking, because this behavior of, if you specify a dilib on the linker line, and then it by default it has to be included even though you don't import anything from it, is total opposite to how Linux does it, and Linux does it the opposite way. If you specify it but nothing is taken from it, then just discard it, and you have to pass in the needed flag. And we're still wondering what to do with Andrew. I was kind of championing the default for macOS, because yeah, it's a nasty bug. Like, honestly, if this is based on bloody strings, and then if you don't link it, then there won't be any warning, or there can be warning, but it's very easy to overlook. And then if you have it running, then that's you done. So yeah, not a very big fan of this stuff. Extra data, nice. Okay, so that should potentially work here. So MIR, RF, ample, instructions, extra, tag index, okay. Okay, I think we should be good to go with this stuff. Wait, let's go back to the test. We have code, we might as well de-init the code for now, and let's have a look at this actually built. By the way, I'm on the AMD Ryzen 7 4800H or something. It's pretty good. It's definitely like the weakest computer that I currently have is the 16-inch Intel MacBook from 2020 or 2019. Can't remember when I got it. It's horrible. It's i9. It's so slow. Like, it actually overheats instantly. Like, if you're running it for 5 minutes, it's already done. And the AMD Ryzen is fantastic. The battery is great on this Linux. And obviously M1 is number one currently. But it's ARM, and it's a really good piece of hardware actually, the M1 SoC. Just very impressed. Print MIR extra. Okay, print MIR. Oh yeah, okay. Yeah, look, you win. Although, you know, I don't know, man. Like seriously, the i9 does not, like, it's, I don't know. I think it's the heating problem, the design with the heating exchange on the on Intel Macs, that is causing this throttling like immediately. Because I've never heard anybody complain about this stuff. Right, and I never heard anybody who actually has like a standard PC laptop complain about this. Like i7, i9 is more than capable, so it's bizarre. I don't know why they did it the way they did it. So, right, print MIR has got MIR. Whoops, extra data was. So here we need print. Here as well, print. I think that was it. No, it wasn't. Crap. Okay, sweet. That should be it. Yeah. Exactly, Hazy Code. Yeah, so you, yeah, so that was very smart. You went with i5. Yeah, I'm not even gonna go there. Like, I have this machine, and it was meant to be great. It's got like 32 gig of RAM, i9, and it's crap. And oh, another disaster is the integrated GPU. Oh my god, it's horrible. It's actually when it's on battery power, I think there is a driver issue. It does like constant switching. Oh. Is it frozen? Uh-oh. Okay, sweet. That works. Yeah. Are you on the i5 2018 Mac? Maybe that's the issue. Okay, don't need that anymore at the moment. Okay, got this stuff. Right. Go back to the thing. MIR RF imp. And I think this will add the stuff into the jinxed yourself, yeah. It's very good. It's very good. Okay, yeah, okay, so got that. Then we want to do what was it? Mir RF imp. We want to have the instructions. Oh, is there a connection? Yeah, maybe try a different browser or something. 'Cause, I don't know what you're on. I have very mixed experience with Firefox, for example. Sometimes works, sometimes doesn't. Chrome is just a memory hog. Tag. Okay, how did MIR ref? I think it was in the emit. Yes. Okay, so we have tag, and then we have an instruction, but we go over this like that. Oh, actually, we want to test a single one. So maybe, do we even need the MIR instructions there? Wait. But actually, all we want to do. would be to do something like this. Yeah, whatever. I can call it var. Or maybe just leave it like const, whatever. And then have an instruction here. But then what we actually want to do, we just want that, and then we don't. I don't think we need all the instructions yet. Maybe I'll just keep adding it as we go. Oh, but it's the index. Okay. I might refactor this later. Because so what I'm thinking about here is, the thing is, I kind of want this like to be almost like a unit test, and so why would I bother with like arrays and stuff? But I might add that later. The thing I need here though is the index, and then we don't have to worry about the array at all. Not very efficient, but hey, whatever. We can work that out later on. Okay, and this will actually, oh, and I'm missing code as well. Am I? Yeah. So I don't think this is, yeah, it's not. Okay, cool. But it's unmanaged, and we need managed. Do we? Yes, we need managed. Okay. So we need that. Actually, you know what? We might as well do that. Array list of U8, and then just do init. Okay, for the moment, yeah, I'm waiting for that too, Reta. I'm definitely waiting for Luke to stream some WASM. That would be cool. Okay, is this gonna work? I wonder. I think I might need to do, I think I might need like a slice or something. I don't think I did that. Passing in the MIR instructions. Oh, whoops. Yeah, we don't want that. And I think here, I think it should be this way. And here, I think we should have a slice function. Yeah, oh man, yeah. So yeah, Luke is saying that he doesn't do well when people are watching. Look at me, man. It's pretty stressful. But it's also fun, kind of like social coding in a way, especially nowadays, right? With the pandemic, everybody's staying at home again, or most people. So it's like socializing for nerds. So that's cool. Missing field code. What do I do here? Oh, it's in it. Yeah, take your time. Look. Okay, this worked. Cool. Right, how do we then compare the output? This is going to be one instruction, so hopefully there's not going to be any junk added to it. But You were oh my god, Reta, you're so mean. We're not competing. You know, we're just having it's a friendly competition. There we go. We're both competing against mold. That's the thing, you know. Beating mold is gonna be difficult. Oh, you mean which one? The friendly competition or beating mold? Items. Right. Now I can't remember off the top of my head how many things we had here. Oh my god, where's online this assembler? Oh no, I hate that one. What we want? So we want 3. Yeah, that's true. He did say it himself. Yes. Yeah, for sure. I mean, he's already winning when it comes to the test for stage 2. As you can see, I'm nowhere near. So I think I even started doing some stuff, but then for Zig test basically passing. Oh nice, you're on Safari. Oh my god, I don't think that's a good idea. Hazy code. Can I recommend any resources for writing a toy linker? Yes, ZLD source code. Or mold source code. I'm really hopeful that it's written in a way that's readable and it's not too complicated. I don't know how many lines in the main file. Yeah, 3000. Okay, but there isn't there's a lot of boilerplate, so but definitely have a look at the code here. Let me paste the link. Send. Definitely that, and then wait, where is it? Just a sec, guys. And then this. I don't know if you can see it. So that's linkers and loaders by John Levine. Yeah, the book is okay. For macOS though, it doesn't have any information. And because I started with macOS, that was a bit of a problem for me because there wasn't much. So for macOS is basically I think the source code for LD64, ZLD, like ZigLD, and Mold are your best bets. For ELF, there's a lot of stuff. Plus, linkers and loaders discusses some ELF, and it discusses some COF too. So Windows is also it gets a mention, which is a lot. You know, it's a lot better than what I can say for macOS. Unfortunately. Can I do like equal slices? Yeah, I do. I can. Type U8. Expected is going to be what was this? Let's have a quick look. 48. Whoops, 0x89 E5. So FinCC, did that help? I hope it did. Some of the recommendations. I wish I had more, but most of basically the way I was writing Macro linker, which actually nowadays it's coming, it's basically biting me back. I was just reversing. So I would use LD64 for some isolated test cases, produce an executable, look at it, and try to infer what is happening. And because I did that, so basically I like subconsciously, I had no idea, well, subconsciously, unwillingly, I was actually reversing the final binary already had optimization passes, like the link time optimizations and other things that Apple is doing. And at the time I had no idea, and I was implementing with this in mind, so I was jumping through the hoops that I normally would not have to. And now, for some cases, this is coming back because some things cannot be optimized, and they're presented in the right form that is then optimized. So I'm actually learning how to do it unoptimized way, and I'm backporting that in because I think the general idea should be that we will always, for the back, we want unoptimized, like not in the slightest, so that we can link in the fastest possible way. And then for release release mode, we want the linker to run a few additional passes to actually optimize stuff. But yeah, looking at how other linkers are doing it is very educational. So okay, let's have a look. I wonder if it's gonna actually pass. Yeah, no problems. Yeah, I think I also read through every single article or blog post that was available in Maho, like the Mako file format. There was one other guy. He had books, like even he had some bits available online, but they're not anymore for some reason. Was it like macOS internals, or was it Darwin internals? Not Levine, Levine. Oh, Levin. Okay, I think it was something like this. So that was oh, nice. There we go. Unfortunately, they're very pricey. As you can see, it's like $90. And as far as I know, they're only shipping from the United States, I think. In the end, I didn't actually need them, but they seem to have a lot of interesting stuff about the Darwin kernel, like XNU kernel, and how things are working underneath, like DYLD and things like that. So he's saying that will be relatively future-proof. So yeah, that's not. Things are changing. Like Apple doesn't basically Apple doesn't care about backwards compatibility. I already noticed that LD64 on the latest macOS Monterey, so that macOS 12, I think 12.1 now, on ARM, so on M1, they are doing they've repurposed some of the sections, and the binary looks different. So this is more learning for me because things have changed again. They are using the same approach that I noticed in, I think, Bexar already, or Catalina, with optimizing thread local storage, in the sense that they don't actually use a separate section for pointers, and then effectively wasting 8 bytes, but they are sticking in like offsets that are relative to the start of TLS data or TLS BSS. I can't remember, one of those. And I think the same thing is happening nowadays, but that's not documented anywhere. This is basically, you either read I'm gonna post that. You either read you either yeah, of course, look, you're competing, I know you are. Yeah, you either read what the binary is, what binary you get, like basically trying to reverse it, or well, there is master reference, although it's lagging with respect to the releases. Wait, let me think. I actually use it on GitHub. I don't think it's official. But when was this? The 4th of March. Yeah, okay, that's not very new. And things have changed. But that's so this is for anybody who wants to write yeah, exactly. Look, the implementation is a spec, unfortunately. Did it not go through? It did not go through. Oh, goody me. Oh, Lotus is back. Hello. Hey, is that maybe an escape? Maybe this. Nope. Okay. Something did not really work very well here. I don't know what happened. Do you want me? We can do a quick pause. Uh-oh. Yeah, okay. There should be like send somewhere, right? Yeah, there is. Remote message. Look, it's here. It seems like it went through. Maybe it's Twitch. Loris, I don't know. I mean, I don't see any error in the logs, to be honest. It's okay. Don't worry about it now. I mean, we can definitely have a look at it later. Oh, there we go. Yeah, it must have been Twitch. I think, because it doesn't seem like any problem with Bork, to be honest. Oops. Hey, okay, excellent. So this so you got something here. Some. I'm wondering. Yeah, I guess this is the best. We would like to test it this way, right? Have it basically compare the actual opcode, the actual encoding of the instruction, I guess. So with this in mind, and then later we can actually, maybe not in this stream because I don't think I will have time, but maybe in a subsequent one we can actually optimize this out, or maybe I'll do it offline, like clean it up so that we don't actually have to specify all of the instructions like this. Maybe we can just do with without that. But anyhow, so this is reg, so this is the destination reg, source reg, and then here the thing we wanted to look at actually. Yeah, thanks, Hazy Code. Actually, I would love to watch that. If ping me when you do the game dev. I would love to even help out if I could. I never wrote a game, and I always wanted to try my hand at it, but I don't know. It's one of those dreams. Right. Wait, we are in the Met. Okay, we're here, and then we test that stuff. We don't actually want to test this because this is easy. We want to test the difficult one, which, for example, was that one. So the flags are that, and then we have two registers. So let's copy that over and let's go down. So so we want to test move, and then we have destination register plus some immediate. Let's do the mock again. Defer mir mock dnet. Okay. Oh, nice look. Yeah, that'd be nice. So yeah. So for the record, I won't be able to stream like next week, and a bit of a So yeah, next week, and then half of the week after that, I'm gonna be at my parents with my daughter. So and I'm not gonna take the entire equipment with me. That's insane. I actually did that once, but that's insane. But I'll be happy to join your stream though. Look. So yeah, I'll be giving you some no promises. You already promised. You can't take it back now. Or if you will, I'm actually gonna go. I'm gonna I'm gonna enter my car and I'm gonna drive all the way to Netherlands and make you do it. Are you happy? Truth be told, I've never been to Amsterdam, like properly. I've only been either flying via Schiphol or basically in the hotel, like basically in the airport area, having a meeting, and that was it. I never actually. So my wife been to Amsterdam a couple of times. My brother-in-law studied for a year at one of the universities there, but I've never been. So definitely gonna visit you. Look, it's not that far. Maybe when the pandemic chills a bit. Okay, so register 1 is meant to be the destination register. Let's call it RBP. Oh, actually, let's call it R11. And then register 2 is meant to be, let's say it's RBP. We need flags at 01. I'm going to encode it. And then data is going to be an immediate. So that's, I think, AMM. Wait, sign the contract, was it? Yeah. Yeah. So I want to stream Elf Linker, look, but it's almost been like maybe not 2 months. No, almost 2 months, like a month and a half since I last looked at it. I don't remember a thing. I'm looking, it's like staring into the void. I'm like, whoa, I did that. Like, what is happening here? So I'll definitely need to brush up my memory on this. And by the way, this is going to interest you very much. So I've been kind of working on adding. Yeah, exactly. I was like, I don't remember any of this. Yep, same here. So I've been working on adding like a standalone, maybe not standalone, but it's gonna be I'm gonna be extending stage 2 test harness to actually test linker stuff as well. I already had some. Sorry, a bit of a digression here. I already had some. Oh, you saw the branch, right? Yeah. So, and you saw that this is actually looking exactly what stage 2 test actually look like. Actually, I want to make it so that with Zig, if you upstream your ZWLD, you'll be able to use it from day one. That's my idea. My idea is that it will be so easy to add new test cases, like we do that with stage 2 tests, so that you can actually start testing immediately output. You can add like a binary parser, because actually Zig it's so easy to write file format parsers, and we already have all of that stuff. So why not? And we don't need anything like a system tool like OTool or ReadElf or whatever. We can actually do it ourselves. And we actually do some of the stuff anyway for stack traces, right? So the idea is that with this, even though you won't be able to run the executable if you don't have runtime or an emulator like Kimu or Darling or whatever, you'll still be able to at least inspect the final binary looking for stuff. And I think we'll be able to actually make it pretty powerful in the sense that for, I'm not sure for WASM, but the virtual memory there is a bit funky, but for standard file formats, we'll definitely be able to add like, is this variable defined at this address or something like this, or does this address have something that we did expect? And I think that would be kind of cool for like really intricate testing. Sometimes it's enough by one error, and then you spend ages debugging, looking like, why am I loading some crap value? And it turns out that everything got like shifted by one. So you're actually loading an incorrect address, for example, which gets dereferenced to something, you know, somewhere that doesn't exist, and you go like, aha. Yeah, and if there is interest in that, I can definitely, I can also stream having fun with debugging mislinked binaries. That's always fun, especially if it happens in release safe. Oh, it's amazing, and it doesn't happen in debug. I had that. Beautiful. Yeah, okay. If you're gonna join me, I'm gonna stream how we're making a debugger, but it's definitely on my to-do list. So. Right, wait, where was I? Okay, immediate. Let's go for 16. Why not? And then, okay. And use local constant. That's correct. And then, I'm just gonna copy that stuff. Size, extra items, move, index. Okay, this is cool. Now then testing, expect. Wild guess, that's gonna be opcode. We need rex because it's wide plus R11. So that's 1, that's gonna be opcode 2. We need immediate as well. I am guessing it's gonna be actually 4 bytes because also mod RM bytes. But let's have a look. So this will be R11 and then yeah, I think it's Q. This is one of the things I need to work out. So this is basically for a memory operand, saying that's a quad word, and I'm not sure when, you know, how to work that out when selecting instructions. I'll need to have a look. Maybe I'm gonna look at how LVM is doing this. Close, assemble, Avengers 4, yay. Okay, so it's 4C, 8B, let's just copy that. Oh, take that. Try testing, expect. So let's see. I wonder if it's gonna work. Wait, what? Yeah, so that was the idea actually. You know, because in Zig we do everything by hand anyway, hazy code. And to be honest, writing a debugger will be a lot of fun in my opinion. And we already have very powerful stack trace printing mechanism. Still need some tweaks sometimes because, you know, you get too many things printed out, and you shouldn't, to be honest. But it's definitely something that I would love to do because, first of all, I want to relearn how it works. Also, that's another thing I'm going to be working on. I don't even know when. We have some memory leaks in the Dwarf parsing code. And that's a little bit annoying because when I was testing with the testing allocator, which is based on the general purpose, it would just flag up that something was not freed for some reason. So I'll need to look into that as well. But yeah, but the debugger will be awesome. Yeah, exactly. Look, yeah. I also wish we had more hours in the day. Okay, let's have a look. So this should lower to that that encoding. So I'm kind of hoping it doesn't, because if it does, then I need to like investigate further, because I thought it shouldn't, or I thought I had things messed up. Like, you know, in, when it comes to like what goes where. I did it correctly, right? It's like, yeah, it's RBP plus offset of 16, memory operand, and then R11. Okay. Okay, so this was fine. Just to be sure. So this was fine. So this is, okay, so I had it. I actually did a horrible job. If this is the case, then that means I had them like in weird orders everywhere. Like I had this, you know, upside down and stuff. Jesus. That's interesting. Huh. Because we have the opposite here, and I wonder if I did it right. Oh, but I always get the same RB. Oh, because maybe the actual okay, maybe the instruction has it flipped already. Maybe that's why I don't. Yeah, okay. So the test failed, which is as expected, I guess. (139.137) because this is a different opcode. And they stay the same? Okay, let's have a look. Okay, I'm actually really glad we did this. So in this case, I would expect that the destination is actually not a register, but this is a, what, wait, am I correct? Um, 1 0, and this would be with the second. Yeah, okay, so the destination is the memory operand. That's correct. And then we have source register. And then, okay, so this is flipped. And it's still R11, which is fine. Okay, right. And the data point is actually still an immediate because we don't have anything else, I think. Do we? No, it's an immediate. Okay, good. And this is memory register. Okay. And I think, wait, what is the, I had opcode somewhere here. RM, this is MR. That one was MI. No, we didn't even have MI. We had RM, which is 8B. Oh, it's 8-9. Okay. And 4C actually stays, I think. Well, let's check it out. So this is we actually do R11 and then we do 0 is 10. And here we have RBP. I love this question by Reda. So look, what else would you work on if you had a few extra hours? Oh, I bet he would write an operating system. Probably in WASM. And that would be awesome. 49, 89, 6B10. Oh, and this changed as well. Okay. Oh yeah, of course, because they're actually flipped. Are they? Yeah, I think so. So it's 49, not 4C. Okie doke. Let's have a look. Oh, I know what I forgot. I forgot to play some music. Damn. I'll need to fix that later on. Oh, compile the stage to compile to WASM. Oh, I love that. Oh, yeah. Yeah, I also want to work on the debugger with you, but yeah, the compiling stage to okay, failed. Did I mess that one up here? Oh no, maybe it's not that one. Yeah, compiling stage 2 to WASM, that's gonna be quite an achievement. Oh, look at this. Uh-huh. So wait, okay, so maybe there is some mistake somewhere here. Oh, yes. Good. So, so reg 1 is meant to be the destination register, but let's just have a look again in the manual here. Yes, reg 1 is the destination, it's meant to be an operand, memory operand, and then reg 2 is going to be RBP. And the flag is 0, 1. Okay, perfect. And the median is, okay, so let's just double check. $49.89.6B10. $49.89.6B10. Okay. And it's complaining. Yeah, I know what you mean. Look, that you're too tired from work to also spend free time programming. Yeah, I wanted free time doing programming. I wanted to go back to my guitar, but my guitars. But having a 3-year-old running around, I don't think that's a very good idea. Plus, I could only play probably in the evenings or at night, and that's you know, I don't know. I need to figure this out. Can't wake everybody up in the house. That would be horrible. Okay, so this is wrong. This is wrong because I think this is a hunch. Oh, and I'm gonna change that. Other tests are gonna fail. Okay, okay. I think it's meant to be this way. And I think, yeah, they're meant to be flipped, I think. Just a hunch. I'm definitely not bloody sure about the sizing here. I'll need to read more about this, how to select the size. And also that one. Yeah, it's dependent on red one. Okay, that's fine. Okay, cool. And because we're probably gonna fail everything in the increment in stage 2 now. I don't want to test that then. Let's just skip them. Yay, I was right. Okay, cool. So I did cock it up. Oh, pardon my language. Okay. So now this is fine. Let's try something else. Oh, this is excellent. This is exactly what I wanted to do. Just to reassure myself that everything is in the right place, which it isn't, as I expected. This is gonna make, actually, honestly, this is gonna make writing code so much damn easier. First step to cleaning it up. Oh my god, yes, good. Right. Okay, these can be tested later on, I think. Because I think in disk, yeah, okay. I think in this case we should be good here. I can do that later. Yeah, that one also, I think. Excellent. Clearly move doesn't belong here. Why? Oh yeah, because, or maybe this is because I made a mistake before. So wait, what is this one? What? Wait, what is happening here? Well, that's a mystery. Oh, is this? Right. Let's have a look. I actually don't remember what that is. Okay, and this one is an... No, okay, this one is also 0p11. Payload, okay, that's not that case. We want 2 registers. And we have it here. Nothing to do. And what is that? Is that genset reg? It is. And we go into register. We have a source register. And we have a destination register. What the hell was this generating? Did I add a note here? I did not. Bad, Jacob. Wait, maybe... Did I have it written somewhere? Do we have this encoding? I think we do. That's MR. Okay, right. I have an idea. RF. Oh, and there was a switch with an if statement. Oh shit. And that's why MIR didn't belong. Move didn't belong there. So this one is a mod array. So this is MR variants. Okay. And then if we go to, we have for other arithmetic operations it's the same as 0p00, but for move this is RM. So it's that one. It's that one. Oh, okay. So I think this one will generate something like, whoops. Wait, so this one is targeting the, so this is the destination, and then we are going to have, for example, something like this. 8B. Right. What if I add so why the heck am I not using a different did we not have it already? Was it not that one? It was that one, wasn't it? Yes. Oh, is this just to make the instruction shorter? Oh wait, modern direct. And for 0p00, this one is also direct, but they're flipped to 1. Okay, let's try it, I guess. So that one would be destination register and source reg with no immediate, I guess. Yeah, I'm wondering, maybe for that one I should definitely, I think I should definitely actually introduce separate emit function for move, because it's got too many variants like this that are confusing. I don't know if this is a good idea just to have them in the same basket. So the destination is R11. Register to, well, let's say it's RBP, whatever. And then flags are this. Whoops. And data is undefined. We don't expect it to actually, we don't expect to actually look into it. Yeah, and then how many bytes was it? Oh, maybe that's the, wait, this is 5D. Okay, let's try and memorize this 5D. Okay, something is wrong here. Oh, wait, no, yes. Is that what it's meant to be? Oh, you mean which tool? Oh, the disassembler. Yeah, but this one's only for x86, 64, and it's actually, I like it. It's pretty useful. There are others, but for different architectures, but this one is pretty useful. Yeah, especially for somebody who just totally forgot what he did, like me. Oh, I know what we could do actually here. This is gonna be kind of cheating, but let's just go with it and let's print the output. Might be actually pretty educational to see what I had in mind. And I have no idea what I had in mind. So this is FMT format slice hex lower. Yeah, that's fine. MIR mock load items. Yeah, let's leave that one out for now. Yeah, this is what I mean. Such a mess. It's funny, but only after a few weeks of actually not looking at this actively, I finally realized how it's meant to be. And now that I did, I'm like, holy shit, I made so much mess. Oh yeah, you mean, Loris, you mean waiting for the thing, yeah. Is there a reason why you prefer byte arrays over string in your expected equal slices? Wait, Loris, wait, 4CBB, 4C8BDD. Oh, I'm confused. So this is the exact opposite of MR. But and what if I do this? Are they semantically different? Anyway, Loris, is there a reason why you prefer byte arrays? Can you point me where exactly? You mean here? Wait, here. If right, isn't it not more natural to have expect slices? Oh, you mean because it also can be treated as a string? Yeah, okay. So then I just get rid of the type, right? I don't know. I mean, it's like Luke saying, it makes more sense to have it as equal slices because it's actually a hex encoding of the instruction. Even though it can be represented as a string, and I would leave the string if we had emit to assembly, and then compare it this way. Basically, if we have the same output in Intel syntax, for example, like that here. Wait, so I don't understand, Loris. Then how would I write this down here as a string? Maybe I'm not understanding. Oh, okay. No, I can do that. I can do that too. Yeah, that's a good idea. I don't. It's not really preference. I just did it because it was just that's how I would write it normally. But I completely forgot about the thing that you can actually do strings. Yes, exactly. Me too. Look, I thought you were actually talking about expect equal strings. Okay, so the tricky thing here is I don't know why we need this at all for move. This is yes, expect equal strings exist. Let me show you. Expect equal. It's got nicer printing, I think. But I think down underneath it uses expect. Oh no, it doesn't. Oh, I think it's scanning for maybe new line or something. What we actually need, and I couldn't see it here, is something like expect equal in a string or something, so that you actually like index of with nicer output. But that's you can always do it yourself. But sometimes a fuzzy search is what you need, and not exactly like a strict comparison, right? So, oh my goodness. Okay, right. I'll need to investigate this. Yeah, does it? Yes, you're right. String, but they're both right. There's string literal and there's array literal. So, and there is also raw hex. So it gives you in all three. Yeah, I know what you meant. Yeah. So yeah, I think for me when it comes to bytes, I'm just used to looking at hex dumps that are. I think object dump does array literal, not a string. Wait, let's have a quick look. Something cool. It's elf. It is temp. Yeah, well, it doesn't do it. It actually does in between. it's a raw hex, but yeah. Oh, by the way, object dump is fantastic. Just wanted to say, it's really good. And I think I kind of missed this, but there is an object dump on macOS, by the way, if anybody was wondering. Or if there isn't, then I don't know how I have it, but I have it. Yeah. Okay. Right. Let me do this trick. Loris was teaching me. What is it? Full screen. Okay, I'm gonna finish. I think it was a good streaming session. Once I get more comfortable, I can actually keep going a bit longer because it's like what, 2 hours or something. And in the meantime, let's try and raid. So that's what Loris was teaching me, and Greta, he's here, so he can point me, like actually give me pointers. Do I just click on this pink, big pink, with a quick action raid channel? Is that how you do it? From your admin panel. Yeah, I'm in the stream manager. Is that the raid button? Okay, I think this is it. Aha, channels you follow. Lol. I need to have some followers, I guess. Who else? Oh, JT maybe. Yeah, no. Ta-da. Toggle bit. How do you do that? If you don't know how to raid, choose toggle bit. Okay. And then wait, select, press raid. Start raid, right? Wait, again. Submit the raid. Okay. Okay, hopefully this worked. So then press rate, then submit the rate. Once you've done that, you can turn off OBS. Excellent.